Okay, so we'll use the calculator sparingly, but do have them out. We're going to go ahead and formally write down our observations from yesterday and then apply them to a couple of graphing questions and then go from there. Okay. So today we're going to focus on graphing all the different versions of sine. So A sine bx plus c plus d, and the same with cosine. Okay. Now, we already know what most of these are going to do. There's only going to be one that'll kind of throw things off a little bit, but it won't be very hard to see how. What did A affect? Amplitude. Very good. And let's just go in order. B is going to affect something else. Okay? If you're not sure how, think about something like sine x and compare that to sine 2x. What does this 2 do to your angle?
No, it makes it narrower.
Don't think shape. I mean, literally, what does this 2 do to x, to the angle? It doubles it. So, in order for the sine graph to complete one period, does it make sense that it's going to make it go through one period faster? Right? Faster. Okay? In other words, here's how we know. We know that sine of 0 is 0, right? We also know that sine of 2 pi is 0. And in between, when we did the graph yesterday, we had this other one, sine of pi was also equal to 0, right? But now think about, in order for us to get our zeros, what values do I have to plug in for x? 0 would still give us this first one, right? But now, what would x have to be so that this is pi now? X would have to be pi over 2 in order for it to be pi, right? What would x have to be so that this becomes a 2 pi? Pi. And now we're done with the cycle. So instead of the period going all the way to 2 pi, I plugged in 0, I plugged in pi over 2, and I plugged in pi, and I'm done, right? So you guys see how that cuts it in half? All right, if you don't believe me, you can real quick go to your graph from yesterday. Original will be light, and the double x1 would be bold. So there's our original graph. And now you can see from here to here is one period, as opposed to here. Actually, let's make it even better. 0, 2 pi, negative 1, 1. So this is exactly the graph that we did yesterday. Here's the new graph. So by the time it gets to 2 pi, our new graph has gone through how many periods? It's gone through 2 periods, right? Now, if I make this into a fraction, say a half, the new graph should do what? So what's the period going to be for that one? It's going to be 4 pi. It's going to double. Okay? So, B affects the period. And here's how. The new period is always 2 pi divided by B. So whatever this b value is, that will tell you how to find the period. Okay? Now C, we investigated a little bit yesterday, right? What did C do?
Left or right?
Shifts it left or right, right? That's called a phase shift. Okay? So left or right, whatever C is. But just like with the period, if there's a b value here, check this out so that you can believe what I'm saying. If I factored out a b, not that we would, but just to see one time what it's doing, if I factored out a b from this, what do I get? X plus c over b. So whenever there is a b value here, this is your true phase shift. Okay. Yesterday, the ones that we moved, we didn't have a b value besides 1, right? But when there is a b value, you're going to have to take c over b to figure it out. Okay? D is nothing new. What do you expect D to do? Up and down. Okay? Now, if you want to be successful at all these graphs, the easiest way to do this is to always pay attention to your period and find a new scale. Okay? What was our scale usually? Pi over 2, right? Because we counted by pi over 2s for all our important points. We have to figure that out for each graph. So if I take 2 pi and divide it by 4, that's where our pi over 2 came from yesterday, right? Remember how we cut it into 4 sections? Okay? Our new scale is going to be whatever our new period is divided by 4. Oh, shoot, let me rewrite that. Okay? And then that'll tell us how to count. If you can write down all these details, then filling in the graph is a piece of cake. Okay? Because all it is knowing how it moves, where it moves, what the new period is, what scale you should use. And then if you know your parent graphs, which you do at this point, right? Where does sine start typically? 0. And then you know the motion, right? What does it do after that? It goes up, comes down, right? How does cosine start? It starts at 1, and then it goes all the way down to 0 and back around, right? So as long as you know those two things, graphing these is not going to be that difficult. Okay? So here's an example. We'll do 2 examples together, and I'll have one for you guys to try on your own. Okay? Let's say we wanted to graph 3 times the cosine of 2x minus pi over 2. Okay? We're going to write down our amplitude first and just go through everything we need to find out. So what is our amplitude here? 3. Yes, good. Our period, which is calculated by what formula?
2 pi over b.
So let's plug that in. 2 pi over b is going to be 2 pi over what? 2. So our period is pi. So our period is getting smaller here. And our scale is just the new period divided by 4, right? So in this case, our scale should be pi over 4. And there is a phase shift because there's a minus inside of the cosine function. And how do I find that? C over b, yes. So let's plug that in. C is pi over 2. I'm not going to write negatives at all when I do this. I just know, and you should know, that which direction is this going to move it? To the right. Okay, so you would write, so after we figure it out, pi over 2 is the same as pi over 2 times 1/2 if you need to figure it out. So what is the phase shift? Pi over 4, which direction? Good. So this is what I would expect you to write. Amplitude is 3, period is pi. Our new scale is pi over 4. But we're going to start our graph. So here's the important part. Start the usual graph here. Okay? And if you can do that, we're in good shape. Okay, so draw an axis. Go to pi over 4. And this is where I'm going to begin my cosine graph. Again, I'm being very deep. You're not going to do it like this every time, but so right here at this x value, that's where I'm going to focus my graphing. Okay? What was the scale? So that means I'm just going to count by pi over 4. Increase this by pi over 4, we get 2 pi over 4, which is pi over 2. The next one would be 3 pi over 4. And the next one is pi. I need 4 spacings, right? 1, 2, so I need one more point. What's the next one? 5 pi over 4. So this window will feature my usual cosine graph. Does that make sense? What are the y values that we need to write down here? 3, -3. And we are in good shape because now instead of starting here, everything's going to start at pi over 4. So how does the cosine graph start? At the top, and then goes down. So you're going to fill in, see what I mean, the parent function points. That's not going to change. And you're going to draw your usual wave. And if you wanted to, you could draw more, but you don't need to. All we're going to do is one period. Okay? Yes?
In calculus, do we define, like, I remember it was about which one was it? In calculus, we define the area.
Yes. What you will be doing in calculus is finding the area. So hold on one second. That's trapped under the curve and above the x-axis.
Is that hard?
Not really. Especially if you remember some things about these graphs. Like, for instance, this area and that area, if you look at the picture and just use some common sense, is the same as that area, right?
Yeah.
So in calculus, you assign areas above x-axis as positive, and you assign areas below as negative. So in this case, the integral from here to here would just be 0. That's what that means. Okay? You'll learn some pretty nifty techniques for how to do that, and it's not always this easy where you can just see the picture and say, oh, it's just 0. Okay? Because a lot of times you'll just do from here to here, and that's a little trickier. You actually have to do the calculus and figure it all out. Okay? How do we check this in the calculator? Okay, so let's do that. But we got to change some stuff around, right? Okay, the reason I like going to the calculator is because this gives you a really nice way of checking your graph. Okay? All we're going to do is just copy what I did onto my calculator window settings and just make sure that my picture matches. If it does, then we're good. If it doesn't, then something's off. All right? So first, let's type it in. You get 3 cosine 2x minus pi over 2. And what window should I use? What should the lowest x value be? Pi over 4. And the highest one? 5 pi over 4. Good. What scale did I use here? Pi over 4. And my low and high values for y should be -3 and 3. And if we've done everything correct, our pictures should be identical.
Wait, what was the line name? -3?
Yeah. Okay. So when you're working on your packets or you're doing your homework, this is going to tell you that you got it right. Okay, obviously, if you put all the information on your calculator in, and let's say you messed up the window a little bit, you might see something like this, and you're like, oh, that's looking pretty good, and then all of a sudden, it doesn't go back, right? So then you know that something's off. Okay, so it's a good way to check. Okay. Any questions on how we got all these details and how I drew this picture? Okay. You know what? Let me try to save some time because I want you guys to practice these. Just so that we understand, so I don't have to do this example. What if I put a negative in front of the graph? What does that do? It flips it so that instead of starting here, it starts at the bottom. So you'd fill in an upside down cosine wave. Does that make sense? But all the details are the same. Just flip the points. Is that easy to remember? Okay. What if it was a sine graph? That way I don't have to do another one of those. But I put a negative in front of the sine graph. It would start where? Start at 0, but instead of going up, it'll go down first. So it's like a reverse wave. Does that make sense? Okay? All right. Then you know what? Why don't I just give you one to try? I take that back. Let's do this one together. I'll cut out 2 of the problems, but we'll do this one together. Let's just make it as hard as we're probably going to see. Okay? But just go through the details and we'll be fine. What's our amplitude? The negative amplitude, yeah, it just flips it, right? So it's still going to be a 2 amplitude, though. What's the period? How do I find that? 2 pi over b, which in this case is 1/2. So it's really 2 pi times 2, which is 4 pi. Okay. We want to use our different scale because the period's different. How do I find that? What over 4? The new period. So what's the scale? So we're going to count by pi's. Easy enough. Is I don't think so. Yeah, the other one we counted by pi over 4. Okay. Is there a phase shift? How do I find it? C over b, so pi over 3 divided by 1/2, which is the same as pi over 3 times 2, so that's 2 pi over 3. And which direction? Left. Okay. And again, this is where we start everything. Okay? What else is there, though, that we didn't look at yet? This +1. So we're also going to shift things up 1 unit, right? So let's draw a graph with all the details. And let's start with this up 1 thing, because it's pretty easy to sketch. Okay? If this +1 were not there, what would be the low and high points? 2 and -2. But now we're shifting up 1. So now the new low point will be -1. and the new high point is 3. Does everybody follow that? Okay. Now, this is very helpful to graph so that you don't make a mistake. You know how the x-axis was a great reference for us because we put all those points on the x-axis? All those points are going to do what? They're also going to shift up a unit, right? So what I'm going to do is draw in another line, but dashed at 1. And call this my, I don't know, let's call it the midline. I don't know if that's a thing, but we'll make it a thing. Okay? All right, so we got our amplitude taken care of. So let's just start labeling everything. Where do I start my graph? At
2 pi over 3.
to the left means negative 2 pi over 3. So here's where my graph starts, right? The parent graph begins right here. Now we're going to use our scale and count by pi's. Oh, but this isn't very nice, right?
Do you just add pi?
That's all it means. So if we
Pi
take,
over 1?
yes. So if we take negative 2 pi over 3 and add pi over 1, I don't want to do pi over 1. What should I write then? 3 pi over 3. So really, this is how I want to think about it. And once you know that, then it's easy. So just keep increasing by 3, right? So what's the next value?
Negative pi over 3.
Positive pi, right? Negative 2 plus 3 is positive pi over 3. So if this is at negative 2, then 1 would be somewhere around here. And what would the next value be? If we're counting by 3 pi over 3? 4 pi over 3, very good. Next one?
7 pi over 2.
7 pi over 3. Let's see, I got 1, 2, 3. I need one more, so what's the last one?
10 pi over
10 pi over 3. And this is where we stop. Can you guys fill in the points? What kind of graph is this? Sine, and how does that usually start? At 0, but we're up a unit, right? That's what the midline is for. So we're going to start here, and usually it goes up, but
It's negative.
we have a negative, so that means we're going to go down, and then back to the midline, up to 3, back to 0. So it should look something like that. Okay, and again, a great way to check if you have a calculator handy is to change your window and everything so that it matches what you drew, and then it should fill up the screen exactly the same way that you have it on your piece of paper. Okay? Are there any questions on that? Okay. So let's just get right to this last problem then. And this is focusing on writing equations given a graph. So I'm going to draw a picture up here, and then we're going to talk about how you can find the graph for it. Okay? So my graph is going to start over here at negative pi over 2. And that is exactly my scale. And I'm going to stay between 4 and negative 4. And I'm going to start at 0 over here and just go up and then follow the pattern. So let's say that this is the graph that we're looking at. And our job is to find both a sine and cosine equation. Can you guys look at the pictures and figure out all the details we had to do? Like, for instance, if I asked you to tell me the amplitude, could you tell me what it was? Okay, so that's pretty easy, right? Let's focus on sine first, okay? Do you guys see where I could start a normal sine graph, a normal sine wave? Where would I start it, Brandon? So over here, do you guys see that if I follow the points, where do I stop? Here? What value is this? Let's see. Pi over 2. This is pi. This is 3 pi over 2. Okay. So how long would the period be if I'm going from negative pi over 2 to 3 pi over 2? What's this whole length here from start to end? How much? 2 pi? Okay. Is there a phase shift? What is it? Left pi over 2. Okay, so let's find all the details out. We have A, right? B is found from what? Period or phase shift? From period. And what is the formula for period? 2 pi over... That's the scale. You're thinking of the scale. 2 pi over B is what tells me my period, right? So 2 pi over B has to be 2 pi in this case. So what does B have to be?
2 pi b 1.
B has to be 1. So do you guys see how we're just piecing things together here? We got A, we got B. The phase shift, what's the formula for phase shift? C over B, but I have one of those already. B is 1. And what is my phase shift here? Pi over 2. So what is C?
Pi over 2.
And we're done. So Y would be, what's A? 4 sine, what's B? So I don't need it. X. And then if I'm left, what do I do in here? Plus pi over 2. Okay. You guys see how that works? Just piece together, work backwards, write the equations out, find the missing letters. If I wanted to do cosine now, that's actually a little less work. Where would my cosine graph start? Right here, right? And where does it end? At 2 pi. That's exactly the normal cosine window, right? So, same amplitude, same period. The only difference is that there's no phase shift because we're starting where we normally start. Do you guys understand that? So what would your equation be if it was a cosine graph? Of? That's it. These equations are one and the same. Okay? All right. I cut out a few things, but I want you guys to practice today before we go home. So, however you want to do it, pages 4 and 5 in the packet, you can skip number 10 on page 5.